Okay, now let me start. We have already finished two major portions of trigonometry. The first one was trigonometric ratios. There you learn about 6 trigonometric ratios. Then in the second section we have learned about trigonometric ratios of standard angle. There we found the value of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Now going further, now we are shifting now on to something which is called complementary angles. Now before I go on to solve your questions from the exercises, first I should tell you now what exactly is the meaning of complementary angle. In geometry in lower classes, maybe in class 7, class 8, you have learned something called complementary angles. Now in geometry, complementary angles are those angles whose sum is 90. For example, you can say 40 degree and 50 degree, they are complementary. Why they are complementary? The total is 90 degree. Similarly, I can say 80 degree and 10 degree are also complementary because the total is what is 90. So that means if the sum of the two angle, if it is coming 90, then we say it is complementary. Now you will find that in trigonometric ratios, there is a very good or nice relationship between these 6 trigonometric ratios. And this relation is what we call as complementary angle ratios. Now just to give you an idea about, now since you know the value of what is 0 degree or 30 degree or 45 degree, then you have 60 degree and 90 degree. So these values you already know. For sine, you know it is 0, this is what is half, this is root 3 by 2, this is 1 by root 2, this is root 3 by 2, this is 1, and then this is what is 1, this is root 3 by 2, then this is okay 1 by root 2, 1 by 2, 0. Okay, just to show you a relationship. Now what you can see there is, what is sine 30 degree? Same is the value of cos 60 degree. Now check the value. Sine 30, if this is the value for sine, the second line is the value for cos. Sine 30 value is half, sine 30 value is half, and cos 60 value is also half. Similarly, now if you see some more angle, sine 45 degree is same as cos 45. So sine 45, you see there is 1 by root 2 and cos 45 is also 1 by root 2. Yeah, similarly now if I am going for sine 60 is same as cos 30. So sine 60 value, if you look at that, root 3 by 2, same way cos 30 value is also root 3 by 2. Can it only be shown with only 0 degree and 30 degree, 45 degree, 60 degree? You can show it for all. So here I did 30 and 60, 45 and 45, 60 and 30. I can also show it for 0 and 90, or I can show it also for 90 and 0. You will see the value is same. That means sine and cos, they have complementary ratio. Meaning if you know the value of sine, you can also find out the value of cos. Supposing if I tell you, hey, sine 30, but you don't know the value of sine 30. And if you don't know the value of sine 30, then see 30 plus what angle is 90, complementary. So then 30 plus 60 is 90. So then if you do not know what is the value of sine 30, you can also find out what is cos 60. So because 60 and 30, the addition of 60 and 30 is what is going to give you 90. Since 60 plus 30 is going to give you 90, so if you do not know what is the value of sine 30, you can also say what is the value of cos 60, because what is cos 60 value, same is also your sine 30 value. Now if that is so, then what is the value of sine 45? Same is also the value of cos 45. You can say 45 plus 45 total is 90. What is the value of sine 60? Same is the value of cos 30. So if you do not know the value of any one of the two, so if you don't know sine 60, then you can also say cos 30. If you don't know what is cos 30, then same is also the value for your sine 60. Same way you can do it with 0. If you do not know what is sine 0, then you can think of 0 plus 90. Then you can say cos 90 value. Cos 90 value is also 0, sine 0 value is also 0. Similarly, your cos 0 and sine 90. What is cos 0? Same is what is your sine 90. Such kind of angle, this relation that is seen is what is called complementary angle ratio. Now see, I have shown you here in the example only of sine and cos. That means any angle of sine is complementary with cos. So then tell me, if I tell you sine 45 degree, then if I tell you hey, sine 45 degree is equal to how much of cos, then you just calculate in your mind 90 minus 45. 90 minus 45 is 45, so it is cos 45. That means sine 45 and cos 45 is same. Yeah, and now it doesn't mean that angles, this complementary relation is only for standard angle. So all the examples that I have taken here, they are all standard angle. You can also show this relation with and none is standard angles. Now when I talk about standard angle, see, if I tell you sine 50 degree, now 50 is not standard. Then if you do not know what is the value of sine 50, you can write this as cos 40, and don't forget 50 plus 40 total is 90. So that means whatever angle of sine I tell you, you can tell me the value for same exact value for cos, you only need to subtract from 90. Yeah, similarly if I say, by the way, reverse is also true. I have all example I showed only sine. The reverse is also true for cos. If I tell you cos 10 degree, 10 is not a standard again. So what is the value of cos 10 degree? Now if you do not know what is the value of cos 10 degree, you can say it is same as sine 80 degree. So 10 plus 80 is 90. So sine can be converted into cos, cos can be converted into sine. Okay, so randomly if I take any one value, again here, if I tell you, hey, cos 1 degree, now 90 minus 1 is 89. So you can say it is sine 89 degree. So cos 1 degree is always equal to here 89. So whatever angle I give you, you only have to give me the other angle, which is in fact the subtraction from 90. 90 minus this angle, when you subtract whatever angle comes, it becomes cos. So that means the relationship, that's complementary relationship of trigonometric ratios is not only for sine and cos, it is also for the other four. Sine and cos, they are complementary. Any value of sine you can write in terms of cos. Similarly, tan is complementary with cot. Any value of tan, if I give you, you can tell me the value of cot. For example, if I tell you, hey, what is tan 20 degree? Then you can simply subtract 90 minus 20, 70. So you can say cos 70. So cos 70 and tan 20, they are equal. What is the value of tan 20? So that means what we did with sine and cos, same thing we can do with tan and cot also. Cot can be changed into tan, tan can be changed into cot. So again reversible. So again the total must come 90. Again one thing you have to keep in mind, the total of this angle must come equal to 90. Then sine and cos complementary, tan and cot complementary. Now one more pair, and that pair is cosec with cosec with sec. So cosec and sec are also complementary. If you know any value of cosec, you know it is complementary with sec. Okay, let's take one example. If I tell you cosec 80 degree, okay, I am randomly taking one angle 80. Now if you do not want to write down the value for cosec 80, then cosec 80 is exactly same as sec 10 degree. So that means cosec and sec, as you can see 80 plus 10 total is 90. So that means cosec and sec, they are complementary, tan and cot are complementary, and sine and cos are also complementary. So if I give you randomly any angle, acute angle, angles which are less than 90, then you can give me the complement to that. So again I am repeating, you can write the complement, but you cannot combine sine with cosec. Sine has to be always, it has to be complemented with, in fact complementary angle with sine is what is cos. Cos is changed into sine, sine is changed to cos. You can do that. Tan can be changed to cot, cot can be changed to tan. And similarly cosec can be changed to sec, and sec can be changed to cosec. The thing is that what you have to do is, you cannot mix again sine with tan, sine with cosec. This again I am repeating, what they are again sine with cos, tan with cot, and your cosec with sec. Alright, then what you have learned just now, now let me give you in the form of a formula. Sine 90 minus theta. Okay, if you like you can take it as a theta. Theta is any angle, but this angle is acute. Acute means less than 90. Sine 90 minus any angle is always equal to cos of that angle. Sine 90 minus theta. Again I am repeating, sine 90 minus theta. And now you may be wondering, what is the meaning of this? Now think about sine 40 degree. Now how am I going to change this sine 40 into cos? So what we will do? Change always this in the form of 90 form. 40. How to write? 90 minus 50. 90, don't forget 90, if I subtract 50 I will get 40. So every time whenever you are solving the question, whatever angle is given to you, convert in the form of 90. Now you may say, sir, 40 I can write 50 minus 10 also. I can write 60 minus 20 also. I can write anything you like, you can write. But since we are talking here about complementary angle, you have to write always in the form of 90. So this angle sine 40 can be written as sine 90 minus 50. 90 minus 50 is 40. Then according to our formula, sine 90 minus 50, there our theta is 50. Then this I can write easily equal to cos 50 degree. So sine 90 minus 50 is what is equal to cos 50 degree. So that means whatever angle you have subtracted here, that angle is what is equal to or exactly equal to that cos 50 degree. Okay, so continuing with this one. So sine 90 minus theta can be written as cos theta. Then reverse is also true. So reverse is true means what I did with sine, now I can also do the same thing for cos. Cos 90 minus theta is what is equal to sine theta. So what we have done here, so same thing can also be done with cos. Cos can be changed to sine, as I said, sine can be changed to cos, and cos can be changed into sine. Now, same way, tan. Tan 90 minus theta is equal to cot theta. So sine and tan. Then cot 90 minus theta is what is equal to tan theta. So same explanation can be given. Then one more, you have sec 90 minus theta is what is equal to cosec theta, and reverse of that, cosec 90 minus theta is what is equal to sec theta. So there you have the set of 6 formulas: sine conversion to cos, cos conversion to sine, tan to cot, cot to tan, then cosec to sec, and sec to cosec. This is what is the conversion that you have. Alright, now as I said before also, this chapter of this complementary angle part is a very easy section, easy exercise. I think maybe initially you may face a little problem when you have, in fact initially when you are doing converting one form to the other one to its complement. So again I am repeating, whenever you convert an angle to its complement, now how usually a question is solved. So okay, I am doing a selected question from your exercise, from your textbook exercise, and the exercise that we are going to discuss now is exercise 21A. Okay, by the way, you have exercise 21B also, but 21B is about finding of values, trigonometric values for non-standard angle, which is in not in your class 9 syllabus, but is there in class 10 syllabus. So as we are going to learn in class 10 syllabus, then yes, you will be requiring one table book, one red table book is what you have to get from the bookstore. So now I cannot give you the table book here. So it's very big table, small numbers, plenty of numbers. So that we will discuss it in class 10. As such, in class 9 you don't have it in your syllabus. So we will discuss only 21A. We are not going to do anything about 21B. So then again one more chapter is there now, I think, which is solutions to right triangles. So where you will be making a diagram of a triangle and then statement based questions what we are going to solve there. So that means trigonometry is not yet over. So this plus one more chapter. Alright, here it is then, exercise 21A, question number 1. Okay, 1. So evaluate the following. So you are asked to evaluate, and then the first one is sine 47 degree over cos 43 degree. Okay, so since this is a very simple question, and that's why it is there in the beginning of your exercise. Sine 47 degree. Now if you look at it, now why I told you that this exercise is very easy. You will find that the angles which are given to you, the numerator and the denominator, or maybe side by side. Again I am repeating, numerator, denominator, sometimes square. It really doesn't matter, square, power 4, it really doesn't matter. But now check the two angles which are given to you, or again I am repeating, sometimes it may be given up and down, sometimes it may be given side by side, maybe on the side of one. If the total of these two angles, if it is coming 90, then we can say, we can apply this complementary angle formulas. Again I am repeating, if the total of the two angles, if it is coming 90, then we can say, we can apply complementary. Okay, now let's check the total. 47, 43, if I add this 0, 90, so that means these two angles are complementary. So these two angles, again I am repeating, are complementary angles. So then how do we solve? Then you will either change this one or you change this one, change any one. Now when I say change, you can apply these formulas. Again, change only one, either you change the upper one or you change the lower one, or change one of the two complementary angle. Out of the two angles, change any one. If you want, change sine. If you want, you can change cos. It's your wish. Okay, let me start with changing of sine. So now how am I going to change this sine? Now write sine. Now don't write 47 because I want to change this 47. Instead of writing 47, Even though I'll write 47 only, but I'm not going to write 47 as 47. Now you'll see I'm going to write 47 in the form of 90. So this 47 I'm going to write 90 minus 43. Yeah, 90 minus 43. You try it. If you subtract 90 minus 43, it will come 47. Then as I told you to change only one, I'm going to change only the upper one. I'm not going to change the lower one. So lower one will remain as it is, cos 43. Okay, here it is 47. I change into 90 minus 43 because 90 minus 43 is 47. Hey, if you want, you could have changed the lower one also, but lower one if you change, then it will be cos 90 minus 47. 90 minus 47 is 43. Okay, now if I have written this way, then sin 90 minus theta. Sin 90 minus theta, as you saw in the formula, sin 90 minus theta can be written as cos theta. That means instead of writing sin 90 minus 43, I am going to write cos 43. Again I am repeating sin 90 minus theta. 43 is our theta. Sin 90 minus theta can be written as cos theta. Since our theta is 43, I wrote cos 43. So you can say sin 90 minus 43 can be written as cos 43. The numerator. Denominator also you have cos 43. And now see, the numerator and denominator, both of them are the same. So there you go. You cancel the numerator and the denominator. So there your answer is 1. See how simple it is. Again I am repeating, you could have changed the lower one also, but when you change the lower one, you could have written at cos 90 minus 47. Then it will become sin 47. Upper side also sin 47, lower side also 47. So sin 47 and sin 47 you can easily cancel. Okay, so that is one, the first question. That's why it's the easiest. So let me show you another one. Same question number 1, subdivision 4. Let's see next. That is cot 40 degree. Tan 50 degree minus half, then cos 35, then over sin 55. Now I am going to check now whether angles are complementary. You can see 40 and 50, yeah, they are complementary. So I am going to change one of them. I'll change either the upper one or I'll change the lower one. Change only one. Then here also same, either you change the upper one or you change the lower one, but change only one. So here total is 90, 35 plus 55, total is coming 90. Okay, then let me change one. Okay, let me change the upper one. So I'll write this as cos. I'll not write 40 as 40. I'll write 40 as 90 minus 50, because you know 90 minus 50 is 40. Then on the lower side you have tan 50. Then minus, let this half be as it is. Then inside that bracket, let me put a square bracket or a curly bracket if you like. Then here also I'll change one. Either change the upper one or change the lower one. Let me change the upper one. Cos 35, I'll not write 35, but rather I'll write 90 minus 55. Because 90 minus 55 is going to give you 35. And then here, yeah, again I should again tell you that please change only one of the two complementary angles. Only one of them. If you are changing the upper one, don't change the lower one. If you are changing the lower one, don't change the upper one. See, I changed this upper one, I did not change the lower one. Here also I changed the upper one, I did not change the lower one. Alright, now let's apply the formula. Cot 90 minus theta. Okay, let's see. Cot, yeah. Cot 90 minus theta can be written as tan theta. So instead of writing cot 90 minus 50, I can write tan 50. Cot will change to tan. Don't forget, cot changes to tan changes to cot. Sin changes to cos, cos changes to sin. Cosec changes to sec, sec changes to cosec. So cot 90 minus theta will change to tan theta. And then on the lower side, it is tan 50. Then same way, this is minus half. Then inside again, cos changes to sin. Cos 90 minus 55 becomes sin 55 over this is also sin 55. Okay, so there you go. Upper side, lower side, sin 55 and sin 55 cancel. Tan 50 and tan 50 is cancel. So then now you are left with 1. As you cancel this upper and lower side is 1. Minus this is half into 1. Half into 1 is also half. And subtract 1 minus half. Take the LCM and subtract. Or as you all know, in 1 if you subtract half. So come in 1 if you subtract half. What will you get? You will get half. So there you are. The answer is what is half. So that is what is your question number 1-4. Let me solve one more question from question number 1. Yeah, this is question number 1-7. It is sine 80 degree by cos 10 degree. Then plus this is sine 59 degree sec 31 degree. Alright. Now you can see complementary, these two total 90. Even these two are complementary, 59 and 31, they are also total is making 90. So change one of them, don't change both, change one. Okay, out of these two, let me change the upper one. If you like, you can change the lower one also. Let us change the upper one. So I'll write that as sine 90 minus 10, because 90 minus 10 is 80. Don't write 90 minus 80, okay? So after subtraction, you should get that value. Then change only one, so I'm not going to change the lower one. So lower one is going to remain as cos 10 degree. Here also I'm going to change one of them, either this or this. Okay, I prefer to change the second one. So if you like, you can change the first one also. So first one I have kept as it is. I'm going to change the second one. Second one is sec, and you know sec changes to 90 minus 31 is there. So 90 minus 59. 90 minus 59 is what is 31. So I'm getting it ready. Don't at first only change sec into cosec. First write that angle in the form of 90. Now in the next line I'm going to change sine 90 minus theta. You know sine 90 minus any angle is cos of that angle, cos of this second angle. So cos 10. So lower side also you have cos 10 plus this is sine 59, and then sec will change to cosec. Sec 90 minus theta will change to cosec 59. So previously we had upper one cancellation, lower one in cancellation. Here we have these two cancellation. Very nicely cancellation means 1 plus. But then we have not done any question sidewise. Now sidewise you have sine 59 and cosec 59. We cannot cancel. But if you know that in the very first class we have learned that cosec is the reciprocal of sine. Cosec and sine, even when we are making the standard table, I told you that cosec is the reciprocal of sine. So what I'll do now, if this is sine 59, this cosec 59 I'll write 1 by sine 59, because cosec is the reciprocal of sine or sine is the reciprocal of cosec. So cosec I have written as 1 by sine 59. So now here you go, sine 59 and sine 59. So even when I cancel this, this is 1 plus 1. So here you are, your answer is what is 2. So this is what I was talking about, side by side, top and bottom, upper and lower side, as well as also side by side. When you have angles which are complementary, this is how you solve. Alright, now let us do a question based on square. Okay, all of them are same only thing is that you may get confused when there is a square. So let me do one question based on square. Question number 2, 4. You have here sine square 56 minus cos square 34. So again, it really doesn't matter whether you have a square or you have your equation without a square. So here you can see 56 and 34. Again, they are complementary. As they are complementary, I'll change one of them. Either you change this or you change that one. So anyone. Let me change this first one. So square, let it be as it is. Only thing that will do is that 56 now change into 90 minus 34, because 90 minus 34 if you do, you'll get 56. So instead of writing 56, I wrote 90 minus. I have to write in the form of 90. And don't change the second one, because we have to change any one. Out of the two complementary angles, we have to change any one. So I change this one to don't touch that. That will remain as it is. Then according to the formula, sine 90 minus any angle. So ignore this square. It really doesn't matter. So sine 90 minus 34. Sine 90 minus theta changes to cos. So I'll write cos 34. But as that is a square, so here also I will be putting the square. The formula is the same, but except that if square or a cube if it is there, that is what is retained. So cos 34 now, and then minus cos square 34 degree. Now check this. Both of these are cos square 34. This one is also cos square 34. That is also cos square 34. One is positive, the other one is negative. So positive cos square 34 and negative cos square 34 is cancelled. So your answer is 0. Now don't get confused. Here when I cancelled, I wrote 1, but there I am cancelling and writing 0. When a plus and minus is cancelled, when a plus and a minus, when they are getting cancelled, the answer is 0. All gone. But when you are cancelling a division, so upper side and lower side, when you are cancelling, if everything is cancelled, the answer is 1. So don't forget that. So most of the time, people make the mistake of writing 1 there or writing 0 here. So make sure when it is a division, the answer is 1. When you cancel everything. And here when you cancel everything, where for a plus and minus, as you can see, this is a plus and a minus, so it becomes 0. This is your question number 2, 4.